Hi guys, today we're gonna discuss about the chi-square test, which is a non-parametric test. You can see in this the documentations I have prepared here. And diving into the chi-square test, let's get into the introduction part. Chi-square test measures the dependency between two features. Today we'll see the coding sessions and coding part and the theory part as well. Uh, why we you are using the chi-square test is the reason behind the using the chi-square test is we're gonna test the dependence of the variable with the target variable using one entire dataset which I have already prepared in my Kaggle notebook. Uh, chi-square test to measures dependencies between the target variable as I have already mentioned, and the aim of using chi-square test is to select the features which are highly dependent on the target variable, which is also the same thing that the chi-square test help us to find which columns which features is more significant and which gives the most relevant and efficient output to our models. And the main thing we need to notice about this the chi-square test is which is non-parametric test, so that in non-parametric test we generally use the categorical features, and in the note highlighted here both the input and output features should be categorical. uh, and the below of that line we have the formula to calculate the chi-square values, and here we have the summation of observed minus expected frequencies, square sum of observed minus expected frequency, which is generally divided by the expected frequency only. The notation is given below of this formula. You can see this all we're gonna implement in the notebook using the Python. And major procedures, the steps to calculate the chi-square test, to perform the chi-square test are, first of all we have to define the hypothesis. Generally what we perform in the hypothesis is we define null hypothesis and alternative hypothesis, which are just opposite of each other. Null hypothesis denotes the two variables are independent. Like at first the features which we are gonna test is we initiate it as an independent with the target variable, and we have another alternative hypothesis which shows that there is a dependency between these two variables. I have taken the heart disease with the age as an example to compute the chi-square test. Here we can see it. Yeah, the category and the main features in this heart disease data is old and young is a two category, and the features is categorized into two classes, that is one is young and another is old. And like heart disease positive, the indicates the person is suffering from the heart disease, and negative indicates that a person is not suffering from the heart disease. This is the tabulated. I have tabulated all the data in this table, and the main thing we need to calculate the chi-square test is degree of freedom. What actually is degree of freedom is we can compute by the counting the number of rows and columns from the data sets. Like here above in the table you can see it, we have the two rows and two columns. uh, the one row is followed by world, and another row is followed by young, which is we have the row of 2 and colons also 2. The one is positive and another is negative. Generally we indicates we set this all with the a, b and c, d variables in the statistic in the classes, theory classes, but I haven't defined that in this documentation. Yeah. For this, we have the degree of freedom is 1, because 2 minus 1 row is 2 and columns is 2. Computing this, we have the degree of freedom is 1. And after that, we have to compute expected values and chi-square values. Like uh, for that, we have the main formula is the total sample. We have the total sample is 337, which is like this all data is has came from like uh, I'll tell you later on. For now, let's leave it here. And yes, uh, this is our formula to calculate the expected value. Here we have calculated one expected value, that is for the world age and positive of the positive target, and similarly here is our chi-square value. Like we have defined the formula here, and using the same formula in this steps, we have computed the chi-square value for this world and positive case. And following these same procedures, we have computed and tabulated in here, and like world and s. Here you can see s denote the positivity and world is as it is age 1. Yeah. And original value, I mean original frequency, that means the observed frequency. This observed frequencies came from the total number of world class in the categorical variable of the original data sets. And expected value came from this formula. And chi-square value is here we have mentioned. Likewise, we have calculated all and remaining three chi-square values and expected value. And next step is to test whether our calculation reject or accept the null hypothesis. As null hypothesis tells us about there is no dependency between target and feature variables. Now we're gonna check it out with the in this step 4. Here for we I have already mentioned about the degree of freedom, which is most crucial, which play the most crucial role in calculating the chi-square test. And another major term that we're gonna need during performing this chi-square test is significance levels. Normally, in the multiple cases, if there is no uh, there is no any significance level or not the significance, if a significance level is no has not mentioned, then we take the significance level as 5%. That means here we have a 0.05. And following this and with the significance level and degree of freedom, we're gonna compute or we're gonna check the actual chi-square table, and which we can get from different sites. And in books there have been mentioned at last as a table, multiple table we can get there, and among them we will find the chi-square table also. There is one tail test and two tail test. We will see, I think yeah, positive one tail test only, because chi-square test text only positive one, because frequency never comes in negative. So we generally look the one tail table in the book. And for now with the degree of freedom 1 and significance level, the chi-square value is 3.84, and now for now null hypothesis to be true, chi-square calculated should be less than uh, chi-square tabulated. And that means the chi-square value we have calculated must be lesser than the table chi-square table value, so that we can accept the null value. uh, Otherwise, and or in case if the chi-square calculated value is greater than the tabulated value, we're gonna reject the null hypothesis and accept the alternative hypothesis. Means if chi-square calculated value comes greater than the tabulated value, then there is a dependency between the feature and the target. If not, they are accepting the null hypothesis, means there is no significant dependency between them. Yeah, this is all about the theory sessions, and we gonna dive in the coding sessions. And let's get into the Kaggle notebook screen. Yeah, yeah. Here is your notebook, and talking about the notebook here, I have imported the sklearn scikit-learn chi-square test, which is already built in features in the scikit-learn. And implementing the features, I have computed the here I can say chi-square value and p-value. What is chi-square value and p-value is, like I have mentioned here, chi-square studies the chi-square, the chi2 and stat, and these are the same. Don't be confused in here. The computed test statistic from the data means the formula we have used, that summation of o minus e power 2 divided by expected, which calculates this one value, as we have computed this using this Python. And which is all that is done by the chi-square of the scikit-learn. No need to worry about the whole procedure, that already built-in function has carried it out and all taken our headaches. And beside that, we have the p-value. What is p-value? P-value is generally the probability of observing a chi-square stat at least as extreme as the one calculated under the null hypothesis. Means p-value gonna be our probability value if we gonna accept the null hypothesis or no, reject it, which gonna be determined by this p-value here. But to synchronize with the our theory sessions, I have introduced the critical value also. There is no specific critical value calculation in the scikit-learn chi-square features, but I have imported the chi-square to calculate critical value. I have imported from the scipy stat, which is another what do we call uh, library of the Python for statistics. And as we have mentioned already, alpha is an level of significance in the previous theory slides, and r is number of row. This logic is generally what I have done is the frequent flag. Okay. First of all, I need to introduce in which dataset I have performed this chi-square test. Is that I have the flight data sets from the Kaggle, and all have been downloaded, and all feature engineering has been done before. And today in this video, I have just included this chi-square test only, so no need to focus on all the stuffs like what data sets and EDA, feature engineerings, model testing, and others which are beside this one chi-square test. And this is all about, yeah, I have generally this is our x is our features, and the selected d after selected is our the target variable. and including these two I have computed one that's I have already mentioned. And the main reason of rejections and accepting the null hypothesis comes here. Here I have mentioned degree of freedom with 5, and the critical value for 95% confidence means here we have 5. If we add the 5% the level of significance, then of course 95% confidence level gonna be itself introduced here. And row and colon, yeah, here the logic behind the rows and colon is I have counted any unique gives these functions gives us the total unique variables in the given features. Like if we have in the previous slides we have old and young two classes, and there was like here you can see, yeah, here we have where it was, yeah, old, yeah. Likewise here we have to we have one this is one class and another class is young. Likewise that we have how much, there are multiple, I think 124 unique values, unique variables in the features. That is okay. Let's print it out. Okay. Uh, okay. Here, let's print it out. R. Yeah. Here gonna be, yeah. Here is 124. Okay. It's quite confusing, and let's do it like row. Let's get it into R, and like let's check colons also. Sorry, this is not yeah, colon. Why I is this colons? Oh yeah, for the class variable. I mean yeah, C is 2. That means 0 and 1, which is target variables classes, and row is 124. Therefore, row and colon C is as same as that of previous one, the hard disease data. And here we have computed the critical value, that is this is the logic behind calculating the critical value, and we have did it and where critical value comes like 149.88, which is really high, or let's not say it's high in this data sets, and maybe the critical value is varies from data set to data sets. uh, that's not a big deal. Here now we have two different, like chi-square calculated is 0.60 and p-value. Here is the main reason of that acceptance and the rejections of the hypothesis. If we have if here is the logic, chi-square value, the calculated value, if calculated value is greater than the critical value, then we gonna really reject the null hypothesis. That means we gonna accept the alternative hypothesis. uh, if not, we're gonna reject the we're gonna reject, oh sorry, we are failed to reject the null hypothesis. Here in this case we have the chi-square calculated is so much less than the critical value, so we gonna accept the null hypothesis. That means there is no relation, that means the feature have no any dependent, feature is not dependent with the target variable. You can see here the vast difference between the calculated chi-square calculated and the critical value. So here is the conclusion. You can see conclusion, chi-square value is 0.60, which is less than 149.88. That means fail to reject the null hypothesis. Yeah, the main logic was that is which is the calculated value comes lesser than the critical value. We say this is a tabulated value, and which results us that fail to reject the null hypothesis, and no strong evidence of the relationship, likely not useful features. We can conclude by saying this is not useful features to train the model. And yeah, this is all about the chi-square test. And we come to the end of the video. And thank you, everyone.